Welcome, everyone. Thank you for coming to this track on Android accessibility. Let's introduce ourselves first. I'm TV Raman. I lead the Eyes Free project, which basically does a lot of the accessibility work for Android. This is both framework level work as well as user space applications that we develop. It's an open source project, and you can see the URL to our project right on the speaker slide. With me today, I have my colleague Charles Chen and Tim Credo. And during this conference, you can meet the rest of us from the Eyes Free project. Some of us will be staffing the sandbox. We have a whole bunch of exciting stuff to show you during the next 2 days. So let's kick this off with the next slide, which is the overview of this talk. I'll briefly, at the beginning of this talk, outline what I mean by accessibility and motivate why this is actually fun to work on in mobile space. It's not just about, there are blind users who need to use the phone. Let's do some accessibility work. Accessibility on Android is actually an extremely exciting area to be working on, and it's one very easy way for you to increase the reach of your applications in terms of users, as well as how much usage you get. We'll talk briefly about what the Android platform has built in to make your life easy as a developer in terms of making your applications usable by the largest number of users. We'll then talk about applications that work out of the box, and then talk about how you can go further if you're doing your own custom fancy UIs to add a little bit of UI magic that actually then makes your application equally accessible to somebody who's not looking at the screen, or somebody whose eyes are busy and wants to use spoken output. And then finally, we will talk about what I call going the next mile with respect to building eyes-free applications, which is really about moving from the domain of accessibility as thinking of users with special needs to moving to the domain of usability, which is really building an application that works in a large number of user situations. During the keynote, you heard a bunch of thoughts about Google's overall vision for what Android can do in the home, in the office, at work, at play. And as you sort of think of those scenarios, you'll begin to realize that building user interfaces that are maximally redundant, that are truly accessible, will really make a difference in terms of how your users use and leverage your work. Let's flip to the first section of this talk, which is motivation. So why is doing accessibility, or the way I look at it, building innovative user interfaces on mobile platform like Android exciting? All of you all know why Android is exciting in terms of it being an open platform and allowing a lot of innovation. But let's just hold one of those devices up in our hand and see what all they enable in terms of sensors that are capable of sensing the user's environment and consequently the user's intention, and various output mechanisms that are capable of capturing the user's attention. And at the end of the day, that's what is user interface. User interface is about capturing the user's intention, performing some computes, and capturing the user's attention to convey those results. And your Android phones are amazing in terms of what they can do, right? You have GPS, you have cameras so your phone can see, you have a microphone so your phone can hear, it has an accelerometer so your phone can sense where you're going. And with the stuff that you saw that's coming down the pipe, the sky is the limit, because you can basically connect any accessory up to the phone, right? So when you do that, the whole user interface sort of starts disappearing in the background. And that's really where accessibility kicks in, because now you can actually do more for the user by the user actually doing less. So user interaction is an interesting term, right? When UI is really successful, you actually don't spend your time interacting with your device. You use your device for whatever it was meant for. And flip to the next slide. There is a whole other half of this in terms of why accessibility is interesting, which is it can really change people's lives. Mobile devices, the kinds of things we want to do with the Android platform, can change all our lives. It's not special to somebody who cannot see or somebody who cannot hear. It basically, think of home automation in Android. It completely changes how you live. And then ask the question, what does that mean to users who are typically early adopters of technology? And if you look at the history, people with special needs usually are earlier adopters of technology, because something that you can do without technology, a person who has a special need like blindness or deafness, actually can do it with technology, whereas without technology it's a lot harder. So in that context, right, accessibility on mobile platforms is truly life-changing. And we'll show you some of these things that we've built in the last couple of years. There's more obviously coming down the pipe. So that's really what motivates me and a lot of our team with respect to doing accessibility. And as developers, as you think about Android in the home, don't just think of the blind user. Think of your grandparents. How are your grandparents going to use these cool things that we all build? And guess what? If the interface you build doesn't work for a senior citizen or your grandmother because the font you used was too small, they're not going to stand up and say, I'm blind, I'm not able to use this. They're going to say, I can see perfectly well, it's just a silly phone that I can't see, right? And so building user interfaces that work well is a huge win in terms of usage. Flip to the next section of the talk. So let's quickly sketch out what's in the Android framework. So during the keynote, you saw the Android timeline, right? It's amazing how far we've come with Android as a platform. And that's true about accessibility too. We started working on Android accessibility sometime in 2008 and launched our text-to-speech layer as part of the platform at Google I/O 2 years ago. And shortly after, we built an accessibility API right into the Android framework. What does that give you? So the Android framework basically isolates you as a developer from all the details of different types of hardware and lets you focus on building really cool applications. The accessibility APIs in the Android framework does exactly that from an accessibility perspective, which is where you might typically think of accessibility as this scary, hard problem where you have to think about the blind user, the low vision user, the user might be using a special peripheral, you don't know how those work, whatever. It's actually very, very easy, and that's the reason why we put accessibility into the framework. It's there on every phone, it's there on every shipping phone since Android 1.6. And what the API does for you is that if you code your application using standard Android view elements, your application will work pretty much out of the box for a blind user. You have to do a few things to pay a little bit more attention, which is what this talk is about. And as you do that, you can sort of see what else we built in the last couple of years. The big change last year in Android from an accessibility perspective was pluggable text-to-speech engines, which again is in the spirit of the openness of the Android platform. But what that gives you is that you code up an application, you use the text-to-speech that's on the platform, and it sounds OK. It's there everywhere, it's ubiquitous. But your users can then go to Android Market and buy better voices for a few dollars. And they buy that voice, they install it, and guess what? Suddenly your application starts sounding really, really nice. And it's a win-win for everybody because all the applications that talk sound better. This means people buy more engines, and the more text voices there are, obviously there's more incentive to write talking applications. Flip to the next slide. So accessibility, as I said, is built into the platform. And as a developer, you're probably asking yourself at this point, so what's the hit, right? Every one of us, we are building applications on mobile devices. That's the first thing we ask. What's the hit in terms of performance? The answer is 0. The reason the answer is 0 is because of how it's designed. The way we surface accessibility to the end user is via the settings menu where there is an accessibility option. And even though accessibility is bundled on every phone, nothing happens until you check that. So you have a user who needs that service. He checks accessibility, and he activates one or more what we call accessibility services, which we'll talk about. So an example of an accessibility service might be Talkback, which is an open source screen reader that my team wrote. Now, what happens when a user checks the accessibility option and activates an accessibility service is that the platform then starts raising what we call accessibility events as the user interacts with an application. So you're a user now, you're moving through the various controls in your application. Magically, your application starts raising accessibility events, and the payload of that event tells the accessibility service what's going on. So the accessibility service then starts speaking. And because of this, you actually work very cleanly in the Android multiprocess architecture. So your application runs in its own process. There is an accessibility manager that sits between you and the accessibility services that are listening. Your application raises the appropriate accessibility events through the platform API, goes across the accessibility manager, lands up in the accessibility service, which then does the speaking or talking or vibrating or in the future Braille or whatever else. Right? So that's sort of the overall architecture. And so the main takeaway here is that it's zero impact in terms of performance. Flip to the next slide. So as I said, the way a blind user would use your application, for instance, is by sort of linearly moving through the various controls in your application. And the way you move through the controls in your application, because Android phones come in many shapes and sizes, is with the phone, with the trackball, with the keypad, with the D-pad, and increasingly with swipe gestures on the screen. And so one of the first things you need to pay attention to is that the traversal order in your application is sort of sensible when you're sort of moving through it linearly. However you do it, right, whether you do it through the touch screen or whatever else, a user who cannot see, it has to sort of go through all of your controls at least once in order to get to what he wants. So making that traversal clean and making sure that everything that needs to be interacted with is focusable is one of the first things you need to do. And the other very small thing you need to do is make sure that your controls are correctly labeled, especially if you're making up your own controls. With that, let me hand over to Charles, who can sort of start diving into more details on some of what I just covered.
Thank you, Raman. So I'm going to talk to you about Talkback. So
we're not letting you off that quickly.
Well, we're not done yet. So OK, so I'm going to talk to you about Talkback. And Talkback is a concrete example of an accessibility service. As the name implies, Talkback talks back to the user and lets the user know what's on the screen. So it's our built-in open source screen reader for Android. It ships standard as part of Android, and it's open source, so people can learn from it and extend it. And so Talkback, the way it works is, as Raman mentioned before, traversal through the controls is very important because there are no special commands that the user has to learn. All users simply just navigate through the interface and use the interface just directly by scrolling through it, clicking on things with the trackball and D-pad. And as the user moves through things and generates system events, so such as selection events, clicking events, so on and so forth, these events get raised at the platform level. And Talkback receives these events, processes them, and then speaks the answer to the user. So the user knows that, hey, I now selected this list item, or now I've clicked this button and activated something, or I've checked this checkbox. So it's very easy to use, very simple, very straightforward. But it's very important that the user can get to the controls so that they can navigate and hear what's going on. Now, the other thing is, this model is really nice, but there are some times when you don't want to just speak whatever is happening on the screen. So a very good case of this is, how many of you here have used voice search and done a search with Google? Cool. Excellent. So as you know, it's almost magical, right? You take out the phone and you speak a query, and there you have it. You know, Google does a search, it recognizes what you're saying, and it gives you the results. Now, the problem is, if you're running Talkback, and if Talkback just announced everything, you would hear something like, voice search started. And then you would be doing a voice search started, which is probably not what you were aiming to do. So instead, in special cases like this, we can actually filter on the package name, on the event, and we can say, hey, well, maybe instead of speaking it, we should just play an earcom and let the user know when they can speak, rather than get into a recursive loop where we try to recognize ourselves.
And this feature in the Accessibility API, where you can filter by package name, is actually a very interesting hook for those of you who are developers in the audience. Because let's say you sort of try a very popular application with Talkback, and you decide, OK, Talkback works with that application, but I think I could do better by making this application talk really intelligently. And you decide to develop such an application. So you take the foo application and you develop a foo talk application. You can actually have foo talk filter events by package name, only respond to foo events, and then pass the rest on to whatever other accessibility service the user is using. And what you will get is a market application called foo talk that your user could pull down use it with this really popular application Foo, and get really intelligent feedback from that application and still enjoy the benefits of the platform level access that Talkback provides. So it's a very, very useful feature. It's something that I believe we need to document better and evangelize better with developers, because I personally would like to see those of you who are developers start writing those type of apps, because they're really easy to write and you can provide real value add on the platform.
Absolutely. And the other thing is that we very recently added a new feature, and this new feature is support for a talking keyboard. So this means that from now on, when you use the latest version of Talkback, if you upgrade from market, you'll get a version that comes with a soft IME, and you can use that IME and it will actually speak back to you. So you can type just on a touchscreen. In addition to that feature, it also comes with a virtual D-pad. So for devices which don't have a physical D-pad, you do have a virtual one that works in pretty much the same way. And I'll actually be demonstrating that a little bit later. Finally, we realized that it's very important to have access to all the controls on the screen, whether or not they're focusable, and we are working towards that. But in the meantime, it is very important that you can traverse and navigate through all the controls. So I've talked a good amount about an accessibility service, a concrete example in Talkback. I'd like to focus on what makes a view accessible. So as Android developers, what can you do in your applications so that all the views that you present to the user are easily navigable, easily understandable, easily usable? So Raman actually spoke to a good amount of this stuff already in his earlier statements about how it's very important that we have focus on everything, that you have a good traversal order, and also the importance of labeling all of your controls, especially things like image buttons, right? Because if you have an image button and it just says image button, well, that doesn't really tell you too much. 5 image buttons, right? Which one does what? So it's very important that you clearly label your controls, make sure everything can traverse well. And finally, Raman also mentioned this a little bit. He talked about how you can extend things through the accessibility service, but you can also extend the views themselves directly. And the way you extend the views directly is to simply override the dispatch populate accessibility event. So this is the event that gathers the accessibility events from its children. It will go through all of its children nodes, ask its children nodes what it should speak, and it combines this. So if you're making a complex widget, you can override this method, and then you can provide your own way of speaking it. And I'll go into more detail on that a little bit later. So let's look at how you can create really accessible UIs. So if you came to this talk hoping to see how difficult it was to create something, and you were expecting that, oh, wow, now I get to solve a really hard problem, I'm sorry you're going to walk away disappointed, because most of the hard work has already been done for you in the framework. So if you just stick to standard views that are part of the Android SDK, you'll see that most of the heavy lifting is done. If you use a text view, you use a list view, things like that, they just work out of the box. And there's really nothing special that you need to do there. If you do want to do something interesting visually, such as restyling a button or restyling your list views, those are really just style attribute changes, and they won't have any adverse effects on accessibility. The thing to be really careful about here is just to make sure that, again, that you're labeling things correctly, and that especially things like image buttons and other controls.
And this is something important to carry over when you build your own custom views, because one of the things that Android does really cleanly in the view layer is the separation of layout from the actual logic of your control. So the various layout.xml files that you are used to writing are what help you quickly move your UI among different devices. So when you do a custom control of your own, make sure that you design it where all of the layout stuff is abstracted out into the XML file, because it will both help you take your application to multiple form factors and also make the accessibility part really easy.
Thanks, Raman. So now, if you want to do something a little bit fancier, if you're trying to modify an existing view and perhaps make a composite view, then in such cases, what you can do is, again, most of the work is done for you. You may want to do a little bit of touch-up to make the spoken feedback better and more intelligible. But generally, it just works. So as I mentioned earlier, the Android framework will go to a view and then go through all of its children. So if you just have a composite view, it's just going to take all of its child views and then composite the result and speak it back to the user. Now, sometimes that's not necessarily the best speaking order, and I have an example later on that shows how you can correct for that. But if you do want to correct for that or enhance the spoken feedback, then what you need to do is just override the dispatch populate accessibility event and reorder things. Finally, in the most extreme case, if you wanted to create your own view from scratch. So this is if you just took the base view class and you said, I'm going to do everything myself. If you go that route, that's really the only route where you have to do some serious work for accessibility. Because if you go that route, then you do have to write your own dispatch populate accessibility event and figure out what you need to fill there. Also, in both cases of composite views and complete custom views, you need to make sure that your traversal order still makes sense and that you don't end up trapping the user inside the control such that they can't get out and get to the rest of the application. So let's look at an example of how we can make a custom view more accessible. So for this example, I'm going to use an actual product that we have. This product is called Google Authenticator. It's an open source application. It's designed to generate one-time passwords. So this is for users who are interested in doing a two-step authentication process, where the first step they type their password, and then for a second step, there's an application that they run on their phone. And they click on get code, it gives them a number, and they type it in. And that's an additional physical token to ensure that the user is who they say they are. So we have this open source application, Google Authenticator. It's on Google Code. And all of the code that I'm showing here is actually linked to that code repository, so you can look at it afterwards if you're interested in seeing the details. What makes this really interesting is that there's a view here called the user row view. And this user row view is a great example of a composite view. It's a composite view that contains the username, the generated passcode, and an interactive control, a button that the user can click on to generate a new passcode. So let's look at what the default behavior is like. So I'm actually going to go to a demo here. Let me just get to the right screen.
Settings, launcher.
And it works better if I plug in the audio. OK, so I am going to show two versions of Google Authenticator. First, I'm going to show the unoptimized one, and then I'll show the optimized version. Are we good to go on the demo? Cool? OK. So I'm going to start the unoptimized version first, and you'll hear how it sounds. By the way, I'm going to bring up the virtual D-pad so I can navigate through it.
Navigating.
OK.
Clicked. Clicked.
OK.
Charles at charlesisawesome.net ______ get code. Charles at charlesisawesome.net 937,049 get code. Launcher, okay. Google Authenticator.
OK, so let's go back to slides. So if you look at this, right, that kind of worked, but it was kind of a clunky experience. It wasn't very pleasant, right? You ended up hearing that my username first, which is, if there's only one username, why would you want to keep hearing that, right? And then you heard the number, but the number was spoken as one really, really big number, right? So imagine you're trying to type this into a form field. It's going to be pretty difficult. So can we do something better? The answer is yes. And the way we do something better is we override the dispatch populate accessibility event, and we do it in such a way that we take advantage of the semantic meaning behind that control, so we present it in a better way. So here's how you can do it. So as I said, what you need to do is you need to override this event, and then you reorder things. So the most important thing here is actually the passcode that you're trying to let the user hear. So you should speak that first. You should also break it up so it gets spoken as digits instead of as one huge number. And then in case the user has multiple usernames, you can put the username at the end so they hear it as a confirmation that it is for the account that they think they're listening to. So
in terms of extrapolating what Charles showed there, right, this is something that I personally describe as leveraging the semantics of your application to produce good spoken feedback. So to take it back into your own development world, for instance, if you're writing a shopping application, Visibly on the visual screen, it might make a lot more sense for you to show the product name, some other description of it, and then the price over on the right-hand side, because your eye can quickly scan to the right-hand side. You'll probably discover that if you're doing a good spoken interface, speaking the price and the product name first is probably more important than a long description or the bunch of reviews there are for it. So this technique that he showed you is going to be applicable in a lot of places. And just because you need to do that doesn't mean that you have to do all of the work needed for accessibility. You just need to populate that one event correctly, and you're good to go with the rest of the framework.
Thanks, Raman. And in fact, it's so easy that we can fit the code for doing this in just one slide. And the cool thing about fitting it in one slide is afterwards, it's actually still readable code. So let me go to that. So first off, you just start off with the standard boilerplate that you're going to override dispatch populate accessibility event. Nothing fancy there. And then here you see that what I'm looking at is I'm looking at the pin text. That's the code that gets spoken to the user. And you'll notice that I have a if statement here. So basically, if the user has never clicked anything, then it's basically just all those underscores. So instead of saying underscore, 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 that gets really annoying, right? Instead of saying that, we can just directly tell the user, hey, click here to get a code. And if they've already gotten a code, then we go through and we split up the number into individual digits so that when it gets spoken back, it will definitely be spoken back one digit at a time. Also, we talked about reordering things. So notice how the digits came first, and then at the end, we're appending the username so that it's a much smoother utterance. And finally, we just package it into the accessibility event, and we return it. And that's it. We're done. So let's see how much better it sounds now with the optimized version. So we're going to go back to a demo. Ready? OK. So I'm going to now start the optimized version. And this is still version that's actually on Android Market if you download. So you'll hear this.
Clicked. Get code Charles at charlesisawesome 651729 charles at charlesisawesome.net.
OK.
Launcher, Google Authenticator.
So let's go back to slides. And in fact, let's go to Raman to talk about well-written apps are accessible right off the box.
So let's talk about applications that are accessible out of the box, because we at Google do the work on the Android framework. We do the accessibility APIs. My team even does some IS-free applications. But the nice thing is there's Android Market out there with however billions of downloads that you heard. And it's really, really nice to be able to go to market, grab an application, and be able to use it. So what's involved in actually doing that, and how much success do you have? So years ago, growing up, shortwave radio used to be my hobby. And technology is interesting, right? Today, shortwave radio is this old-fashioned technology that nobody touches. We have these nice smartphones, but yet we all still listen to radio stations from around the world. And so radio stations continue to be a hobby. And so I want to show you one of my favorite applications that just worked out of the box for the most part when I pulled it from market about 6 months ago. It's called TuneIn Radio. It allows you to browse radio stations from around the world and play them with one click. The application was really accessible because it was built with platform-level Android view hierarchy elements. So you could basically use Talkback, scroll through it, listen to the radio station names, browse by location, do searches, click, and play. And there was one minor accessibility problem. In fact, as I prepared this talk, I was hoping that that problem would persist so that I could show all of you how easy it was to fix that problem. So in that process of preparing the talk, I wrote to that developer and said, hey, by the way, look, you do have this little problem in your application. And the problem was that his play stop button was an image button that didn't have a label. Now, I liked this application so much that I basically learned that that particular image button was the play stop button, and I was happily using it. But I told the developer, this is going to be really easy to fix. And by the way, I'm going to talk about your app. Is it OK with you? And he said, oh, yeah, go ahead, talk about my app. And I've already fixed it. That's how much long it took him. It basically, within 24 hours, the fix was on the market. Charles, quickly, you want to show that?
Yeah, sure. We can show that.
So notice that this app works really well in multiple modes of interaction. And that's important, right? It would be extremely ironic if in order to listen to the radio, you first had to sit down on a chair, hold your phone in both hands, and squint it like this. That'd be utterly stupid, right? This goes back to make your application such that it's usable in all the contexts that your user wants to be able to use it in: jogging, running, driving a car, cooking lunch, whatever, right? So just take a look at how easy this application is to use.
Okay, so I'm going to scroll through some categories here.
Music. Local radio. Search image button. Browse. 88.5 KQED FM. Public. Forum. KQED.
So your local NPR station is probably faster to launch with this than with your physical radio, which is how it should be, right? In general, if you actually do the numbers, you will find that if it takes your user a minute to do something, he's going to do it a certain number of times a day. But if it takes him 10 seconds to do that same thing, the number of times that he will use it in a day will go up an order of magnitude. We all wear wristwatches. Well, at least my generation of people wears wristwatches. Charles doesn't wear wristwatch. But see how easy it is to look at the time on your watch, right? And that's how easy you want tasks to be, because when they are that easy, you do them a lot more often. Flip to the next slide of the talk. So you want to pick up that slide, Charles?
Sure. So can we go back to slides? Thanks. So I want to talk quickly about how you can test for accessibility to make sure that your apps are actually going to work well. And the nice thing is that on Android, it's extremely easy to simply test by doing. So what do I mean by that? Well, you don't need to buy some fancy screen reader or spend lots of money, because Android comes with a screen reader built in. So all you really need to do to test it for yourself, to experience what your app would be like for a user that's on a screen reader, is to go into settings and turn on Talkback. It's really easy to do. I can even do it right now. Why don't we actually just do that? So can we switch to demo? So all you really need to do is, on your home screen, if you simply go into settings. Yeah, demo's up. And you go into accessibility, and you just need to make sure that the accessibility checkbox is checked.
Accessibility settings.
And that Talkback is checked. And once those are checked, then voila, accessibility is up and running. That's just how easy it is.
And you heard a number of things today during the keynote about how cloud really makes for a lot of interesting experiences when you get a new device, because you sign in and all your goodness comes through. Accessibility is part of that story. So for instance, if I grab a new device and sign in, it actually starts talking to me, because the cloud knows that my devices talk to me. So the moment that accessibility option gets checked, everything talks, and by default, we can actually turn that option on from the cloud. Let's go to the next section of the talk, where I'd like to talk briefly about sort of moving over from the domain of accessibility and special needs over into the domain of usability, which really starts touching a very large proportion of your users. It touches both your users with special needs and also realizes that all of us are special at some time or the other. There are many times of the day when your average user is functionally blind. There are many times of the day walking through a noisy airport hallway, or walking through a crowded hallway in Moscone Center after the keynote, where your user is functionally deaf, right? So there are these environments where you really want to start building your application to leverage that environment. So let's talk briefly about that. So there are three sort of things that I personally like to point developers at in terms of what it means to build mobile applications that are truly usable in a large variety of scenarios. The first is leveraging the fact that these devices have so many sensors and actuators. It's something I alluded to right at the opening of the talk. So basically, the more that the device knows about the current context, the less you as the user have to tell it in order to complete the task that you are trying to complete. And at the end of the day, that's user interface. User interface isn't about clicking fancy colored buttons or making things go boink and you touch them, right? It's about rapid task completion. And rapid task completion is really the next bit, which is, as I said, minimize user interaction by leveraging the fact that the device knows a lot about you. These things are called smartphones for a reason, right? It's not just a marketing term. There are two reasons why your device is a smartphone. It's smart in the sense, not because it has a gigahertz processor. It's really smart because A, it has a large number of sensors and actuators for sensing and interacting with the physical world, and it's connected to the cloud. However fast your phone's processor gets, the cloud is bigger, right? The cloud, in terms of the intelligence, in terms of your user context, in terms of what you did last on your browser, what you did last on your tablet, that context is huge. And as you leverage it, you basically get to user interfaces that disappear into the background and let you complete your task. And that's the best thing you can do for accessibility. And finally, voice recognition, right? Speech recognition is sort of a technology that all of us in the technology world say is coming. It's come. In fact, it's arrived, and it's arrived so ubiquitously on Android that you don't even think about it anymore. Where 3 to 4 years ago, writing a speech reco application required you to be a real rocket scientist. And I kid you not, when I was working in speech research many years ago, most of the people who worked in speech research eventually became rocket scientists on Wall Street. Because it was sort of the same mathematical techniques that was used in both places. Today, you don't need to be a rocket scientist to write a voice recognition-based application, because on Android, it's one API call away. Recognition happens in the cloud, and your application just gets intelligent. Charles, why don't you pick up the next slide?
Sure. So how can you obtain feedback in eyes-busy environments? Well, you can leverage built-in text-to-speech APIs to generate speech. So, for example, if you're jogging and you want to fiddle with your music player and change tracks, do you want to stop jogging, do this and try to shade it and see what track is playing? No, you want to be able to keep on going with your workout and just keep jogging, right? So here's where you can use the touch screen, and you can use spoken feedback to tell you what the next track is, and you can just stroke it, and it should play, right? We actually have a slide talking about that, Rock Clock. That's another open source application we have. Great for accessibility, but actually it's great for everyone. So when you have an eyes-busy interface, that's a good time to use it. The other thing is, of course, you can use haptic feedback. So going back to a Rock Clock example, right? As you switch tracks, you get a little vibration, a little buzz that lets you know that, hey, something happened. So that, in addition to an auditory cue and the fact that music has switched, that really sort of hammers the point home. And it almost feels like you're using a physical buttons to drive the player. So what can we do to minimize the interactions needed to perform a task? Right? Raman was touching on several of these points earlier. Well, Android devices have many eyes and ears. It's able to sense things. It knows where you are, and it's got many ways of catching your attention. So, for example, it can flash the screen at you. It's got the LEDs. It's got haptic feedback. It can speak to you. It goes on and on and on, right?
And with Android at home, it can turn off the lights in your rooms and put you to sleep.
Exactly. Or turn up the lights and wake you up with really loud music. So user interaction is really about communicating the user's intent to the device and then obtaining feedback from the device. And so I encourage everyone here to think about how you can best leverage these to minimize explicit user interaction and just make things work for the user.
Next slide. So we'd like to bring Tim, our other colleague, up here for a couple of demos for Intersection Explorer and Walkie Talkie. As Tim comes up, these tools.
So Raman, why don't you talk a little bit more about these applications as we resolve the network issues?
Sounds. So while we set the phone up on the network, so Intersection Explorer and Walkie Talkie are two applications built on top of Google Maps. And these were built for a very concrete use case. About 2 years ago, I got dropped off by the Google shuttle, and it was a new driver. So he got it exactly right, except that he dropped me on the opposite side of a very small street. And I did not have Walkie Talkie at the time. I did not have Intersection Explorer at the time. I knew my home neighborhood, and I still walked in the opposite direction from home and actually spent about half an hour wandering around trying to get back home. And so we came back and started building a couple of applications with, at the time, the G1. We originally built a simple reverse geocoder at the time that would actually tell you where you were. And then about a year ago, Google Maps launched walking directions. Walking directions are really nice, and it actually works out of the box with Google Maps and Talkback. But now here is the bit about building a user interface that minimizes user interaction. The default maps interface actually has the flexibility of picking either driving directions or walking directions. That's already one gesture that I did not want to do. We also said for the blind user, not only do you want to speak walking directions, but you actually want to say what you're passing.
We'll use yours.
Is it right?
Yeah, so we'll use Tim's because he has free G and I don't.
Yeah, so we'll put, so Tim's coming up. So Tim will take over from here and sort of talk you through this as he demos it. But it's very useful application, and it's one of the
I have it. Woohoo. Woohoo.
Oh, you got it.
Wi-Fi.
Wi-Fi. So that's great. So demo gods are with us. So
Yes. Yeah, it's up and running. Thank you.
go for it.
Thank you.
So again, Raman has been saying these smartphones have so many sensors in them, and so in a way, it's when you're really designing something for accessibility, you can actually go a bit beyond what's in the system level and take advantage of all these different modes of interaction. So this is, as Raman was saying, Intersection Explorer is a map type experience for someone who's blind, and it uses sort of a virtual D-pad gesture interaction. And Charles, how do I turn the volume on?
Oh, I think we need to make sure this is plugged in tightly.
Move 138.
Oh, can we?
Can
I think
we
the
turn
audio was
demo on,
off.
please?
Could you please make sure the audio is on? It is? Okay.
Okay, I can talk.
Northeast
That
along
is-
Howard. Moved 49 meters to left onto New Montgomery St from Howard. Northwest along New Montgomery. North. Northeast along Howard Street. East, south. Southwest along Howard Street. Moved 49 meters to left onto Hawthorne St from Howard Street.
So you can see as I'm using this, I'm controlling it via gestures, and these are gestures that are going to be independent of wherever I start on the screen, so that if you can't actually see the screen, it's still just as easy
Southwest along Howard. Southeast
to
along
navigate
east.
here.
Southeast
And
along.
the
Move
feedback is being
192
read with the
meters to
text-to-speech
Folsom
API.
St. Cross's Hawthorne
And so,
Street.
in particular, we're paying a lot of attention here to how we're speaking each intersection, so that you get some cues that make sense to you about where you've explored to. In
Northeast along Folsom Street. East. Southeast along Hawthorne Street. East. Northeast along moved 136 meters to 2nd St. Cross's Folsom Street.
So this year, it's hard for you to experience the haptic feedback it's providing. Next year, we'll make the chairs vibrate. But in the meantime, you can believe me when I say that as he moves his finger over it, you can actually feel each street.
Or if you can't wait until next year, go catch us in a SAM booth. We'd be happy to let you try it in person. Or even better, just download it on your phones, right? Because
It
it's
works
all
on any
market.
device. So.
So let's switch to the conclusion slide.
Right. So conclusion. So to sort of wind up, right? What is our simple takeaway from this talk is that just as 5 years ago, if you had to build a mobile application that ran on 100 million devices, it was a huge, hairy task. What Android has done as a framework is made that trivial, where a high school student today can basically learn Java, pick up the tool, the SDK, write an application, and get it running on 100 million devices. Similarly, accessibility traditionally has been huge, hairy, scary, bugaboo thing for developers, where there is a lot of awareness among developers today, thanks to things like the Americans with Disabilities Act and the various regulations around accessibility. So people are aware that accessibility is important, but it's always been a scary thing. Our simple takeaway for you from this talk is that accessibility on Android is not scary. It doesn't require an expert. It only requires you to use the bits in the framework that are already there and test for it. And finally, focus on usability. And focusing on usability, every one of us, when we sort of sit down at our keyboards and develop these applications, there is one thing and one thing alone that drives us. What drives us is getting a lot of users out there to benefit from the insights we have, from the flashes of intuition we have, from the creativity we have, right? As software engineers, just as a painter picks up an easel and a bunch of oils and creates something beautiful, software engineering is as much an engineering science as it's an art, where we are building something, we are creative, And the most satisfaction you get from that creativity is by getting your apps to be used by as large a number of users as possible. So from an accessibility perspective, when you sit down to write your application, think of the widest number of use case scenarios. Don't limit your user base to somebody who's got 20/20 vision, can touch the screen, can speak, can move, can do everything, and is sitting on a chair looking at the screen. Design for the broadest use case and speed up task completion. And by doing that, you will not only make a huge impact on users with special needs, what you will inadvertently achieve with that moonshot is that you will vastly increase your user base and find that your users use your applications a lot more. We'll start taking questions from here. Put up a Q&A slide.
Yeah.
And I think there's a microphone up there that you can walk up to for questions.
There are actually 2 microphones.
There are 2 microphones. All right.
Hello. I had a question. I saw most of the focus of this talk was on vision impaired users. I know, obviously, hearing impaired and movement impaired users. What I guess is mainly the focus with Android on the vision impaired use case. Is that like the biggest hurdle to jump, or what's the other focuses?
So great question. To summarize for the video recording, the question was, is Android accessibility focused on blindness and low vision, or are we also paying attention to other disabilities? The answer is we are definitely paying attention to other disabilities. And as the questioner surmised, a lot of the focus right now is on blindness and vision impairments, because that's where the biggest challenges are. We have another talk later today from our team that sort of gives a higher level overview of all of the accessibility stuff we are doing. And you'll see some very innovative uses of Android for helping users with hearing impairments in that talk. And do come by our sandbox where we can talk in more detail about the various things we are doing. So absolutely, Android accessibility in general and accessibility at Google is not limited to blindness or vision impairments. It's a very broad area.
Also, just to add on to that point, several Android devices are hearing aid compatible, so it's a hardware issue, and several of them do have that. And in addition to that, there are several open source projects that are aimed at other impairments. So for example, there's a university project called Tekla, T-E-K-L-A, and it's using the Android IME because it's an open, flexible framework and letting you control that through a sip and puff interface.
So they're doing it for sip and puff. They're trying to control wheelchairs with Android, all kinds of cool stuff.
Okay, great. Thank you, guys. Good work.
Question? Yes.
Hi. I have a question about where to get support as a developer if I'm writing an accessible application. I had an issue a while ago where a text view with the password tag just simply would not show up whatsoever with accessibility. I couldn't find out where to get support. There's nothing online for accessibility whatsoever. I'm wondering if you guys are going to put up some documentation somewhere about how to resolve common issues or just ways to better write accessible apps, because all the documentation I got was use the content description label.
So a couple things. First is I invite you to look at the links up there. We are improving our documentation. There's also an eyes-free user group where you're more than welcome to ask questions. We regularly read these posts and respond to them. And finally, if you're interested and you have time, I'd be happy to talk to you offline after this to look at your specific app and issue.
All right, that would be good. I think actually, I looked at the Eyes Free project before, but it actually said, if you're a user, post here. If you're a developer, post on Google Groups.
Mm-hmm. That was probably over a year and a half ago. If you sort of look at the overall velocity of Android development, our Eyes Free work and accessibility work has probably matched that. So you may be pleasantly surprised at. Of course, documentation is never perfect, and we could always write more. But right now, I think about a month or two ago, we actually added an accessibility section to the Android dev guide too. So you should probably find a lot of the basic answers in there today.
So the link is up there. Please talk to me afterwards.
All right. Thank you very much.
Yes.
Hi, it's Fritke from Open Intents. My question goes in a similar direction. Do you have some guidelines or some strategy how to make your accessible applications more accessible or discoverable by the user? So do you suggest to add a certain tag to your market description, or so, that people can find you up?
Right. So to summarize the question, are we planning to show developers how to add more markup to their applications? Was that the question?
Well, how find the people my application?
Oh, discoverability.
Yeah, the discoverability.
So please advertise it on the ICE3 group if it is something that is accessible and would be helpful.
Okay.
To this user
So
base.
in typical Google fashion, a lot of this has happened bottom up. I think one of the easiest ways for users who need accessibility to discover applications that are accessible is through a website that I call Android Access, I think, that is actually allowing users to post reviews of applications. So you can actually go to that site and see what users who need accessibility think of particular applications. And in the last month, I've actually discovered applications from there rather than actually pulling down applications from market and playing with them myself. So somebody else is actually doing that work already, and it's crowdsourced, right? It's a whole bunch of users doing it. So definitely do that. Google for Android accessibility. Do a Twitter search for Android accessibility. You'll find a lot of resources that are grassroots and actually work very, very well.
Yes, ma'am.
I just wanted to clarify the previous question. He was asking, can you flag an app on the Android market as we're a very accessible app?
That's a great question. So can you flag a market application as an accessibility application? It's a feature request that we've received. It's a feature request that I myself have raised. I don't know at what point something like that will become available, but that's great feedback to hear. We'll definitely take it back.
All right. Any other questions? Anyone? Okay. Well, thank you. And
Thank you for
please
coming.
attend our next talk.
Look forward to seeing you guys in the sandbox.